Okay, so the second way of creating VZ is by specifying its PE size. What is PE? Is nothing but PE, physical extent, is nothing but every physical volume can be comprised of equal number of chunk of data space, equal number of divisions, that each division is known as physical extent. Suppose if you're having a PV size is 1 GB, okay, so if it is divided into 250 equal number of divisions, that each division size is 4 MB, that each division is known as PE. Okay, physical extent. Okay, so the size by default in LVM2, by default the size is 4 MB. Of course we can vary it from 4 to 128. So previously we have created a VZina. By default its size is 4 MB, the PE size is. But you can change that PE size also. Okay, like this by using this command. So here simply you must mention while creating, simply previously we have created VZ create and name of the VZ. So that VZ was created with default size of that PE. Default size is 4 MB. Okay. Mm, now if you want to change the size of that PE, specifying that size, you need to use -s command and size of PE, how much size you want to. Previously I have default it is 4 now. Now we can change that 4 by changing it. You can use 16, 32 like that. Okay, so we will see that one. After creating that one, you can check it by using pg display command. Okay, in the same way, LV also will be created by specifying number of LEs, not size of PEs. Okay, what is LE? LE is nothing but logical extent. So logical extent is nothing but again same concept. Every logical volume is divided into some equal number of divisions. Each division is known as logical extent. But this LE is linked to PE. So LE is mapped to physical volume. LE is logical extent. PE is nothing but physical extent. These are same. The size of LE is size of PE. So for example, if the size is 4 MB, physical extent size is LE size also 4. So LE size is decided by PE. If it is 16, LE size also 16. Okay, but if you want to create an LV with some size, you must mention the number of LEs only. You cannot mention the size of LE, because size of LE decides by this PE. Okay, you can do that by where here you can change PE size here. Okay, after changing it, you can use like this. Okay, suppose if I want to create an LV with this size 400 MB. Now I need to calculate the size of the number of LEs it is having. So how to create that one? First you must know PE size. Let us consider the PE size is 16. So obviously LE size also 16. Okay, now so now you need to calculate how many LEs the LV is having. So here the LE, here the LV size is how much I want to make, 400 MB. Okay, now 400 MB. So 400 divided by 16, size of PE, is equal 25. Okay, size of LE is same as size of PE. So size of PE is 16, size of LE is also 16. So the size of LV required is 400 MB divided by, in MB you must mention it in MB, if and divided by size of PE or LE, both are same. 400 by 16 is equal to 25. Okay, suppose for example it's the size of LV is 2 GB, you must convert it into MB, that is 2 into 1024 by size of PE, which is equal to 128 number of LEs you need to use. Okay, by that way you need to calculate it before doing that. And you must remember that the size of LV must be converted into MB, because the PE size or LV size is in MB only, not in GB. Okay, after doing that, after knowing how many number of LEs are required for creating LV, you must use this command LV create -small m. Previously we have specified the size of LE, so where there we have used capital L. Now we are specifying the number of LEs. So if you use small l, that will consider, the kernel will consider the number of LEs. Okay, if you use capital L, that will consider the size of that LV. So small l, number of LEs, how many? 25 hyphen N this previous, like previous one, LV name and VZ name on which we are creating. Okay, now let us check this on practice session. uh, so already we're having this VZ1. Now I need to create new VZ. Okay, for that I need a new PV. Okay, you must create new PV. So already I am having some partition on my SDB hard drive. these two are already on VZ1. Now I am having one more SDB one. Okay, this is for Linux LVM type only. Okay, now I use this as a PV. Okay, just now I have deleted it now, removed it from VZ1 now. Now I will make a new VZ with this PV. So PV create /dev SDB1. Okay, so successfully created. Okay, now what you need to do is, now I want to create a new VZ by specifying its P size. Okay, so further the syntax is VZ create name of that VZ and -s small s and size of PE and PV. I am taking the size of PE size as 16. Let us check previously how much the size of PA. So previously I am having VZ1, only one VZ. Okay, to know complete information about that VZ, you must use VZ display. If you use VZ, it will show like this only, how many VZs are there. It will give these details. If you want complete details about that VZ, you need to use VZ display, that VZ name. You must mention the VZ name also here. Okay, this command will be helpful to know what are the VZs we are having. If you don't know VZ name, then it will better to use this VZS command. If you know the VZ name, you want to know entire information about that VZ, you will use VZ display. Similarly, same case with LV display, PV display, PVS and VZS. Okay, same criteria. Now check it. The VZ existing VZ name is VZ1. System ID format, it is LVM2 type, that is version of LVM. Right now on 7 RHL7 it is LVM4. 3 is over 4. Okay, but we are using RL6 and LVM2 version only. Okay, these are the some of the details about that one. Read write access, resizable and current LV. Okay, current PCs, look here, by default if you create a VZ, previously the VZ was created by default, that means VZ create VZ1, simply VZ1 and that PV name. So by default kernel will create like this, 4, the OS will create the VZ by taking default size of this physical extent. So the default size is 4 MB. Now what our aim is, we want to create a new VZ by specifying the P size also. I want to make a different VZ with a different PE. Okay, so after this calculation, the total size of VZ is 3 GB. If you divide this 3 GB with 4, you will get total number of PEs in this VZ. So out of them 258 are allocated, 513 are free. These 258 are allocated to some other PV. Okay, free are these things. Okay, next, now I want to create a new VZ by using VZ create. Okay, here I want to specify, look the syntax, VZ create name of the VZ. Okay, and the size of the PE, and now I want the size is 16. Previously for old VZ it is 4. I want to make it different. So VZ create, I want to name my new VZ as VZ2 hyphen I size PE size. So I'm taking 16. Okay, 16 MB. My PE size is 16 MB. I want to consider, and you must mention that PV STB 1. What we have added 1. Okay, it will take some. So okay, now VZ2 was successfully created. Check it, VGS. look here, new VZ was there. Previously it is only one VZ1 only. Now new VZ was created, it is having only one PVs. In VZ1 we are having two PVs. LV was not taken, any LV was created on this VZ. On VZ1 we have one LV. These are attributes, forget about it, you will see later. Size of that one is 1 GB because only 1 GB PV was added, so total size is VG is 1 GB. It is free. Okay, now you want to know clearly you want to see this P size of this newly created VZ. Okay, so for that what you need to run is VZ display, and you must mention second VZ2. Now look here. Okay, so new VZ created with VZ2, name VZ2, and look here, the P size is 16. Okay, 16. Okay, if you don't use this syntax s-16 default it will take like this only, 4 GB only. Okay, for VZ1 I have not mentioned that one, so for VZ2 I have mentioned the size, so it was created. So this is another way of creating a VZ by specifying its physical extent PE. Okay, so that we can create a VZ in two ways. Okay, without specifying PE size, with specifying PE size. Okay, that's how we can create a VZ by using physical extent. Now our task is, now I want to create an LV by specifying its number of LEs without specifying its size. Previously if I want to create LV, I need to specify its size. I want to make it different. I want to specify its number of LEs only. I don't want to specify its size. Okay, for that you must do calculations in prior before executing that one. So what are the calculations you must do? First you need to check the size of LE. The size of LE is same as size of PE. So here in our example it is 16, so size of LE is also 16. How much space you require for LV is 400. Let us consider it is 400 MB. So the number of LEs on that LV are 400 divided by 16, which is equal to 25. You require 25 LEs to create 400 MB of LV with a LE size of 16 MB. So calculation is over. Next step is you need to creation of that LV. So for that the command is LV create hyphen small l. Previously it is capital L. If you use capital L, that will take the size of LE. If you use small l, that will take the number of LEs. Of course it doesn't know whether that number is size, only by specifying this option only. If you use small l, then it will consider it as number of LEs. If you use capital L, then it will consider the size in MBs. Okay, and n is name of that LV, and on which VZ we are taking that LV. Okay, that is syntax. Let us execute it. Okay, so right now we don't have any LVs on this VZ2. Now I am creating new LV by using LV create command on VZ2 na. So first then how to do that one is hyphen small l. How many logical extents I'm having? 25. How we get it? I need 400 MB of LV. 400 by physical extent or logical extent size is 16. 400 by 16 equal to 25. 25 number of LEs are required, and I want to name it as name my LV as some LV2. LV1 is also already there, LV2. So for that I need to use hyphen small l, name of that LV, and on which VZ we are creating? VZ2. Check it. Yes, LV2 was created. Check it by using this command LVS. Previously we are having LV1, it is on VZ1, the size is 1 GB. Okay, now we have created it is using different notation, that is by specifying 25 number of LEs, each one of size 16. So 25 into 16, 400 GB. Look here, size is. If you want to know more information, use LV display. The name is, okay, sorry, you must always mention the LV like this path. You must mention the path. Don't simply mention LV2. Okay, look here. The size of LE is 400. On VZ2 it was there, LV2 was there. Okay, next size, number of LEs are 25. Okay, it is specifying the number of LEs, current LEs. Okay, so 25 400 by 25 will give you 16. 16 is the LE size of LE. That's how we can create a new LV by specifying the number of LEs. After that, the regular procedure will take over. That is, you need to format it with a file system. After that, you need to mount it to some mount point. That is a regular procedure. Okay, that's about creation of LV and VZ in a different way. Okay, next, one more topic is our next, how to delete a volume group. Simple. To delete a volume group, make sure that if there is an LV in it, okay, if there is an LV in it, it is mounted, you must unmount it before removing VZ, because if you don't unmount it, the data on that LV will erase. Okay, so in real time what they will do is, you must unmount that LV, you must move that LV to another VZ. After that they will delete it. Okay, simply by using VZ remove command we can delete that VZ. Next, how to delete PV, already in this video already you have seen. Next, okay, in the same way you can delete LV also. Simply LV remove command. Okay, I will show you one by one. Now task is, how to delete LV. So sorry, VZ. LV VZ. Yes, I'm having two VGs here. I'm having two VGs, VZ1, VZ2. I want to delete VZ2 now. Before doing VZ2, I want to know whether there is any LV was there on that volume group VZ2. For that I'm using this command. Okay, look here, VZ2 is there, LV2 option is there. Next, check, or you can verify that by using df-h, or in df-h, oh, sorry, I have not given that in fs tab, that's why it's not showing. Okay, lvs command or lv display command also, because of course I have not formatted it using file system, that's why it is not showing. Okay, so I have not mounted it now, that's why it's not showing. Simply do that by vz remove command, vz remove vz2. Simple. Okay, if lv is mounted on that, if lv is mapped that one on vz2, if mount point is attached to lv, you must unmount it. Okay, simple. It will ask yes, yes, simple, that one. If you want to remove lv, lv remove entire path, you must give, for lv you must give entire path, vz2 lv2. Of course vz was removed, lv was default removed. We're having only one lv na. Okay, one lv. Now I will remove this lv. Okay, how to remove that lv? First you must first you must unmount that lv1. Lv1 is mounted on /lvm_dir. Okay, first unmount lvm_dir. Next, lv remove /dev vz1 /lv1. Yes, okay, it was removed, but you need to do one more step. Okay, it was removed temporarily, but it was there in /etc fs tab. /etc fs tab. Okay, it was there. For the next reboot, it will reappear. So for that, you must remove this entry also. Okay, you know how to do that one by using VA and go to that entry, last entry, DD. It was removed, and save it. Escape, shift colon WQ. Okay, that's over. Now check it. It was not there. After reboot, that LV will not do. That's how we can remove LV, VZ, PV, all these things. Okay, thank you.